I'm just going to make a quick answer key here for the homework that was assigned and try to follow all of the rules that we came up with. View number one, spread of smelly particles in a hallway. I'm going to make smelly particles be triangles, and I'm just going to show 3 of them. Outside of it, I'll keep it easy, show 5 of them. All of those particles are moving, and they're moving kind of randomly, so I'm going to show whooshies going in all directions. It's a little harder in the can. You say triangle equals smell, circle equals air. That's before the spraying. I'm going to say that one of those stays in there. It doesn't matter if you said that or not. But at time 0, both of those guys were kind of there. Air particles are staying constant. They're still moving around. There would still be way more than this. This guy stays in here. By now, maybe one of the triangles is there, and one of the triangles is there. Okay, if you wanted to show some of these bouncing off the walls, you could. But this isn't really about pressure. This is about just the spread of the smell. Again, there's maybe still one in there. And then now maybe the triangles, the smell has spread all the way there. Okay, that keeps it nice and easy and still follows all of our rules. Okay, let me go down here. This one's pretty similar. Whoops, whoop, whoop, don't do that. Skunk spray. Same thing in here. I'm going to make these be triangles inside the skunk. Actually, let's say that the skunk got rid of all of them. Air, we want to show our 2 different substances. I'm going to, again, keep it simple. Show some whooshies. Recently sprayed. Now the 2 smelly ones are out there. Okay, and then now that we're detecting the smell, okay, maybe there's another one here, and then 1, 2, 3, 4. They're all the same size. Mass is staying constant. There's not really any volume on this because this would all be outside. Let's take a look at the second page here. Full tank propane gas. Okay, now this one is about pressure here. So I'm going to show a few more, and I'm going to show that this one bounced off, and this one bounced off, and this one bounced off. That way I have 3 pressure events happening here. For 2/3 of a full tank, now the thing that changed is that there's less particles in there. So I'm just going to say that instead of there being 6, now there's 5. And there should probably be a little less pressure in there too. So instead, I'll fix this one a little bit here, make it easier. So now I'll say that only 2 pressure events happened. And if I scroll down here a little bit more, oh, those are going to go with it. This last one here, instead of having 5, maybe there's only 4 particles in there now, and maybe only we show 1 pressure thing. So there we're showing pressure is going down because gas is escaping out, but that they're still moving around inside of there. Okay, number 4, it says n equals 20. I'm going to draw 20 particles here. That seems like a lot. 4, 5. I am going to kind of draw them in a pattern just because it makes them easier to look at. And then I'm going to draw some more down here. I'm not sure that you had to do this, but it kind of makes more sense to me. And then 1, 2, 3, 4, I don't know, 5. Okay, they're all moving around. It's pretty random. This isn't really showing the sides of the container as much. Make sure I get little whooshies on all of my particles. Okay, that's before the fan turns on. Now, it depends on what you think about this. Now, you could say that, more particles are in there when this fan turns on. That's why I kind of showed the ones down at the bottom so that we could keep particles constant. Now, these particles are moving faster, which we haven't really talked about that yet. I'm going to draw these as hitting the person, just to kind of show that that's what made it all happen. And I'm also going to show that these particles down here at the bottom are now outside there. So how many have I got so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, 15, 16. Okay. So to me, that kind of represents that a little bit better, that now the air is above the fan and that it's hitting the guy, making you go up in the air. Okay, it's higher inflation. I'm going to go with correct inflation first. I'm going to do maybe 6, 4, I'll do 5. For this correct inflation, I'm going to say, again, it doesn't really matter, but I want to show that there's some pressure here and that these other ones are moving. Now I have something to compare for. So underinflated, which would mean that there's probably less air in there, so maybe only 4 of them, and your tire's low on pressure, so maybe only 1 of them is being shown as hitting the sides. Overinflated would mean maybe there's more, and now maybe they're hitting the sides too often. 1, 2, 3. If I wanted to, I could even draw a 4th or a 3rd, because I don't have any numbers to go along with this bouncing off of that. Last one here, particle picture for a person on top of the mountain. This one's a little bit different. We didn't have a chance to talk about this. Think about the Earth. I'll draw the Earth over here. Okay. And then let's say that this is the edge of the atmosphere. So Earth down here, outer space up here, and then here, this whole part is air. So we're talking about being up here as opposed to being down there. So the pressure that's on you, when they talk about air pressure and pressure on the weather and all that kind of stuff, they're talking about the pressure that's pushing down on you at the top of a mountain. There's less air above there. So they say sometimes the air is thin. Ooh, I didn't mean that to be a squiggle. And what they mean is that there's actually less air above you. So I'm going to just draw 3 particles there, and I'm going to show 1 hitting the person on top of the mountain. Whereas down up, the person at the bottom of the mountain, he's got all this air up above him going up here. So 1, 2, maybe 3 are hitting him. Oh, we're under all this pressure all the time. Right now, air particles are hitting you in the face. Because above us, we have way more air kind of stacked above us in a column. Okay, so that one's kind of different one. You may have had to think about that. Hope that all makes sense. Let me know if you have questions.